So students, let us do one more problem based on trigonometric identities. Let us see what the problem is. See here, we have given secant theta plus tan theta equal to p, and we need to show that p square minus 1 by p square plus 1 equal to sin theta. Got it? So what we have to prove, let us write down first. Okay, we need to prove okay, here p square minus 1 by p square plus 1 equal to sin theta, right? We need to show this. So in this consider this as LHS part, this is LHS, and this would be what? RHS. So we need to take LHS part and we need to obtain RHS part as usual. Okay, take LHS first. Okay, LHS equal to p square minus 1 by p square plus 1. Okay, p square minus 1 by p square plus 1. Now let us do one thing. Substitute the value of p over here. Okay, just see what is the value of p. Secant theta plus tan theta. Just put down secant theta plus tan theta. Since here p square is given, so we can put down whole square for that, and here minus 1 is there, so this is p square minus 1. Now again p square plus 1, what it is? Secant theta plus tan theta whole square, and this would be plus 1. What I did, I just have substituted the value of p and I wrote the expression. That's it. Now what did you observe in the numerator part? This is in the form of what? A plus b whole square, and here denominator also same expression is given, so we can expand it or not? Yes. Do the expansion in which form? A plus b whole square form. What is a plus b whole square expansion? A square plus b square plus 2ab. Now do that in this pattern. Okay, a square means what? Secant square theta plus b square, that would be your tan square theta, plus 2ab. Okay, 2 secant theta tan theta. Expanded this. Now we need to write minus 1. Okay, write down minus 1 here upon. Just see here also same expansion we get or not? Secant theta plus tan theta whole square. Write down same. Secant square theta plus tan square theta plus 2 secant theta tan theta. Okay, here plus 1. Okay, now just see, let us do some rearrangements in the numerator and denominator parts so that we can solve it. Okay, what we have to do here, just do here, this is secant square theta and here minus 1, group them together. Here just see 1 plus secant square theta, here minus 1 is there, so we can write minus 1. Okay, plus this is tan square theta plus 2 secant theta tan theta upon. Now do one thing here. Consider here in denominator part, group the terms tan square theta and plus 1 first. So 1 plus tan square theta. Okay. Now what are left over? Secant square theta plus here 2 secant theta tan theta. Okay, now why I grouped these terms only, it comes to know. Okay, just see. Now what can you say about secant square theta minus 1? Is it tan square theta or not? Now take the help of second trigonometric identity, that is secant square theta minus tan square theta equal to 1. Now if you take this 1 to this side and tan square theta to another side of the equation, then what do you get? Secant square theta was written, and then after plus 1 will be converted to minus 1 when we take it to that side. Now tan square theta will be converted to minus tan square theta will be converted to plus tan square theta. So this is one relation. Okay, and another part, secant square theta minus tan square theta equal to 1. Now take this tan square theta to another side and leave it as it is. Secant square theta equal to 1 plus tan square theta or not? 1 plus tan square theta. These are the two relations. Means we wrote secant in terms of tan, tan in terms of secant. Now what can we do here? Here secant square theta minus we got or not? So secant square minus 1 theta can be replaced by what? Tan square theta or not? Yes. Just put it down. So this can be, so this expression can be written as tan square theta plus tan square theta plus 2 secant theta tan theta. Upon. Now 1 plus tan square theta will be written as what? We can replace this 1 secant square theta. Okay. I mean, we can replace this 1 plus tan square theta with what? Secant square theta. We can put down here secant square theta. Write it down. Secant square theta plus. Now this is secant square theta. Plus this is 2 secant theta. Secant theta tan theta. Now what did you observe? What is your observation now? See here. If you observe carefully, so what is your next step? Tan square theta plus tan square theta would be what? 2 tan square theta plus 2 secant theta tan theta upon. Here secant square theta plus secant square theta, that would be our what? 2 secant square theta plus 2 secant theta tan theta, right? So here we simplified up to some extent. Then what we have to do next? Simply if you observe the numerator part, secant theta, so your tan theta is a common factor. Understood or not? In first term we have tan square theta. In second term we have 2 secant theta tan theta. So tan theta we can take common from numerator part. Similarly, from denominator part, 2 secant square theta, 2 secant theta tan theta. From that secant theta can be taken common. Let us do it. Taking tan theta in common, what do we get here? So tan theta we took common. So what can we write here? 2 tan theta plus 2 secant theta. 2 tan theta plus 2 secant theta. Now what can we take common here? Secant theta we can take common. So let us do secant theta into 2. When we took common 2 secant theta, here 2 secant theta will be left over. 2 secant theta plus 2, okay, tan theta. So here 2 tan theta will be left because secant theta we took common. Okay, so like this. Now just see, anyways we can take common 2 also, but anyways that will be cancelled. No, we don't need to take common there. Here 2, here 2. If you take, it's good. If you don't take, then also it's good. Okay, anyways this is 2 tan theta plus 2 secant theta, and this is 2 tan theta plus 2 secant theta. Both numerator and denominator part gets cancels. So what is left over here? Tan theta upon secant theta. So we have simplified this, but still we didn't obtain the answer because our RHS is in terms of sin theta and cos thetas. So what we have to do, we need to convert this all the expressions in numerator and denominator part into sin and cos expression, cos terms. So tell me here, how can we write tan theta? We can express tan theta as a ratio of sin theta to cos theta. So how can we write it? Sin theta upon cos theta, this is a fraction, upon secant theta can be written as what? It's a reciprocal of cos theta, no? So therefore secant theta can be represented as 1 by cos theta. So in this fraction we have we have fraction in denominator part, so therefore it will be inverted. So what do we get here? Sin theta by cos theta into cos theta by 1. Okay, this will be reversed. So we can cancel here numerator and denominator part, cos theta. So what is left over here? Sin theta, right? So this equal to what? RHS. So we obtained our RHS. So therefore for this problem LHS equal to RHS. So problem is solved. Understood? Like this we need to solve it. It's a very normal problem. Generally by substituting the value of P and thereby expanding it and taking some common terms and cancellation. cancellation of the common factors from in numerator denominator parts, simply we can obtain the value. Understood? Like this we can do it.